Hi, welcome back to my channel, and I hope you all are doing great today. So let's start with our chapter here again. Welcome back again with the electrochemistry is welcoming you again. So in last lecture, basically we have studied. We will just recap to the previous lecture, and then we will continue to our lecture over here. So in previous lecture, here we have seen the non-standard. What we have seen, non-standard non-standard electrode potential calculation. We have done that part. Potential electrode potential calculation part we have seen. Okay, calculation part we have seen in our previous lecture. So here we have seen like non-standard conditions were there, either of any condition, like T must not be equal to 298 Kelvin, or we have taken concentration which is also not equal to 1 molar, or the pressure, it, it is not equal to 1 atmospheric pressure also. Okay, so this any condition, if it is not followed over here, this will be considered as a non-standard electrode potential. And in this particular thing, we have studied about Nernst equation. We have seen the Nernst equation over here. Okay, we were talking about the Nernst equation. So Nernst equation we have seen, that is, one is delta G gives free energy change. It is equal to NF E cell, NF of E cell. This is our Nernst equation. And also for the standard condition, also for standard, this is for non-standard part. This was for the non-standard part we have seen. And after that, we have seen for the standard condition. For always remember, whenever we say standard, we use not over there. So NF E naught of a cell will be there. And to calculate E naught, this will be for the standard condition. We use a standard condition over here. Okay, standard condition will be there. And to calculate E naught of a cell, one more shortcut will be there. That is E naught of cathode minus E naught of anode. This is simplified now. So till here we have also seen, and again we have seen Nernst equation for any temperature. Okay, Nernst equation for any temperature, any pressure, for any temperature, for any pressure, for any pressure we have seen, or any molar concentration. So it was nothing but, that is, it was represented as E cell, that will be equal to E naught of a cell minus of RT N F ln of Q. Okay, so till date, like in previous lecture, we have seen up to here for any temperature calculation. Now today we will be seeing, that is the most important part again. Again, we are going to use this particular formula over here. So in generally in exam also, you will be having few values. The values of T298 Kelvin, it will be given. 298 Kelvin, it will be given, or it will be given as a 25 degrees Celsius. In any question, if you see a question, so in that particular question, if you have 25 degrees Celsius, so we can rearrange this Nernst equation formula. So how we are going to arrange it? So suppose if temperature we are taking 298 Kelvin, and ln of V, that is nothing but log to the base E, and to convert this log to the base 10, we use 2.303 into log to the base 10. So these are the conversion factors which are very much important, that we are going to use over here. Okay, so what we are going to do, we will just write it again. That is E cell, it is always equal to E naught of a cell. Okay, and R, that is universal gas constant value, that is 8.314. I'm using with this reference, okay? And temperature, we are taking temperature 298 Kelvin divided by F is what? Faraday value. We have already seen that. So N into 96500. And one more thing, we are converting this ln to log. So this will be nothing but 2.303 over here. Okay. And then we have, that is log to the base 10 of Q. Okay. So this is a simplified thing. So it will be a cumbersome every time if you want to calculate this much area, this much. So what we are going to do, we will be using this value. We have a certain calculation for this particular value. So instead of that particular value, we will be writing over here E cell, that is equal to E naught of a cell minus. So it will become, after calculation, this value will be 0.059 divided by n, that is n factor, remains as it is, and into log to the base 10 Q. So this is simplified example. One more formula, simplified formula. And for when we are supposed to use this formula, only for temperature when we take 298 Kelvin. Okay. So this formula again we can use for non-standard electrode potential calculation. And we still have two formulas. That is, we can also use delta G also, Gibbs free energy chain. This is also a Nernst equation formula. This formula for standard calculation, and this formula E cell is, that is equal to E naught of cell minus RT NF ln of Q. So we can use this formula for any temperature, any pressure, and we have just rearranged the few things over here, and we got the conclusion over here for temperature 298 Kelvin, because in most of the question it will be given as 298 Kelvin. So we are just simplifying this terminology over here for our better understanding over here. So now whenever we go towards or look towards the non-standard equation, okay, non-standard calculation, so there are total 5 cases that we need to remember. Okay, so we will be seeing each and every case over here. So Nernst equation, let's move towards the Nernst equation. First case we will be seeing over here, Nernst equation for fuel cell. Nernst equation for fuel cell. Nernst equation for fuel cell. And this will be our case number 1. This will be our case first. And this case first, this deals with same electron, or we can say that whenever we have a same electron or same charge, so we will be seeing a cell where we will have a same electron or a same charge over here. Yes. So for this one, we will take a question, very short question. The question will be like that. We are taking zinc rod with in ZnSO4 solution, and we are taking this solution as, now we are taking the 0.01 molar. So if it is a 1 molar, we have to take this particular thing into a standard condition. Now it is 0.01 molar, so it will be a non-standard condition. And here we represent this particular part as, now copper +2 will be there and copper electrode will be there. So this will be like this, and here concentration should be written 0.1 molar. We are writing this also. Copper is in a solid form. This is also in solid form. These both are our electrode. So this is a representation of electrode. Basically a cell we are using over here. That is a galvanic cell, representation of galvanic cell. So we are using this. This is only one line representation. We know that this is our positive side, this is our negative side. Okay, so what we have to do over here, what we are asked over here, find out ERP. sometime it will be given ERP, sometime it will be written as EMF, sometime it will be written as E cell. Anything will be written over here. Find out ERP or EMF of cell at temperature 298 Kelvin. Temperature 298 Kelvin. We have just seen this particular thing. Or temperature will be given as 25 degrees Celsius. Just remember this particular thing over here. So what we have to do over here now, we have to identify which term is oxidizing and which term is getting reduced over here. So we are very much familiar with this particular thing. Zinc is getting, like we can see that zinc is converting to Zn plus 2. So we can write this equation, that is one more thing that is given over here, E naught of Zn plus 2 Zn, it is given, that is minus 0.76 volt. This part is also given, and E naught of Cu plus 2 Cu. So this part is also given. So this is nothing but plus 0.34 volt. So this part is also given. Now let's talk about the answer. That is very much important part. So what we will be doing over here, we will be first seeing where exactly oxidation is taking place and where exactly the reduction is taking place. So let's write over here, that is Zn, it is losing 2 electrons, Zn plus 2 and 2 electrons. So we know that oxidation means this is our anode over here. Yes, this is our anode over here, and this side is our cathode over here. Okay. So zinc is giving 2 electrons over here, and that particular electrons are gained by that particular copper. Cu plus 2, this gains this 2 electron and converted to Cu. So here we can see that for N factor, whenever we talk about the N factor over here, here we have an N factor. Here we have an N factor that is nothing but, so this N factor over here we are having. So N factor means number of electrons are there. Okay, number of electrons are there, number of electron taking part. So number of electron will be nothing but 2 electron. We can see on both sides we are having 2 electron. So this will be our N factor over here. This will be our N factor over toward this side. So N factor is 2. N value will be 2. We have to take over here. And now we will be, like here we have 298 Kelvin. So we will take same charge, same electron. For this condition, we are talking about case number 1. We have a formula, E cell, it is equal to E naught of a cell minus, now let's take an example, the formula 0.059 divided by N log to the base 10, and that is Q. And Q is nothing but concentration of, that is this oxidation. Consider this Q will be represented as concentration at anode and divided by concentration at cathode. Okay, or left right we can also write this, or left or right part also. So now this will be nothing but, we can write over here. First we will, this formula that we are going to use. So E naught of a cell will be nothing but equal to, what is at cathode? E naught at cathode minus E naught at anode over here. Yes. So what is at cathode? Cathode we have seen. So this will be our plus 0.34 minus in bracket. At anode we have how much? 0.76 volt. So simplified, this will be 1.1 volt. Okay. So we got E cell value. Let's talk about now Q we have seen over here. Let's calculate the Q also. What is the concentration? This is concentration C1 upon C2. So concentration will be equal to concentration of 0.01 and whole divided by 0.1. So after calculation of this particular thing, we get 1 upon 10 over here. So this is simplified over here now. So let's put the values and get the answer. E cell for this particular equation will be 1.1 minus 0.059 divided by 2. 2 is nothing but our n factor, and log to the power to the base 10 and to the power like this. This 10 will shift to the numerator side. So we get over here 1.1 and then 1.1. So this minus 1 will come toward the, okay, I will solve this one again. 0.059 divided by 2 and log to the base. This is our log formula that we have to use. Minus of 1 will be there into 1. So this whole value become over here 1.1 plus 0.059 divided by 2. So this will be written as 1.1 plus. I'm just solving each and every step so that you won't get confused over this. So we get final answer, that is 1.12954. Okay. So this is our E cell value. So the case one was all about the same electron or a same charge. Okay, we are talking about same electron or a same charge. So in this is simplified thing that we can do over here. So this is case one, it is done. Now let's move towards case 2 over here. Let's talk about case 2. Okay, case 2 is very much simplified. Now here, first we have taken same electron. Now we will take an odd electron over here. So case 2, we will be talking about odd electrons. Odd electron over here. So let's take an example. Our example over here, it will be dealing. Here we are taking magnesium. Okay, magnesium as a solid, and magnesium sulfate will be there. Mg plus 2. And the concentration for this particular term is 0.01 molar. Let's take under, and this is our cell over here, and Ag plus and Ag will be there. This is our solid, this is our positive side, this is negative, this is cathode, and this is anode over here. Okay, so Ag have a concentration 0.1. So from here we can see that Ag plus, there is odd electron system. We can easily see that particular thing. And same terminology, temperature is 25 degrees Celsius. Okay, so now it is making our work easier over here. E naught of Mg plus 2, E naught of Mg plus 2 to Mg. It is nothing but minus 2.36 volt. Okay, and E naught of Ag plus 2 Ag. This will be nothing but 0.8 volt. It is given over here. So this is all about our question over here. Now what we will be doing over here? So we will just see over here, we have a formula that is E cell. We are very much familiar with this formula now. E cell of E naught of a cell minus 0.059 divided by N and log to the base 10 of Q. Now we are going to use this formula. First we will see what exactly, which kind of a reaction is taking place over here. Basically Mg is converting, Mg over here it is losing 2 electron, Mg plus 2 is converted to this behavior. This shows this behavior over here, and Ag plus over here is accepting 1 electron and it is converted to Ag. Now as we have an odd electron over here, we have to multiply this term by 2. If we multiply it by 2, then and only we can just remove this electron to just equalize them. So this will become 2 Ag plus 2 electron, and this will be 2 Ag. So what we have to do, we can understand from here. I'm just giving you a shortcut trick over here. So whatever will be the charge over here, just cross multiply it. So 2 will be multiplied with this one, and Ag will be multiplied with this one. Whatever charge will be there, we just need to multiply it. So this is our concept over here. Now we have to just take over here. What we are going to do, we are just going to take only small thing over here. That is nothing but this part over here. If you want, you can calculate this part at homework also. That will be an easier thing, because it will be like here. Now we will be taking, like, both will, two electrons are there now. Now just take the values E cell, just calculate the E naught of a cell. E naught of a cell for this particular equation will be nothing but here. Now we can see that this is our anode, this is our cathode. Mg, what Mg value is nothing but minus 2.3. This is our anode, and cathode is nothing but over here 0.8. 0.8 plus, I'm directly solving 2.36, so this will be 3.16 volt over here. Okay, this we got over here. And for Q, now let's move towards the Q. Q, we are having concentration, this is our C1, this is our C2. Now here we have concentration, this should be multiplied by 2 now. Now this multiplication we are required over here. So anode is nothing but 0.01, and here we have, that is 0.1 square. So after solving this, we get 1 over here. So we also got the Q over here. Now let's put the values and finalize our answer over here. E cell, it is equal to, that is, we got 3.16 minus 0.0599. Now you must be thinking what n should be there. N should be 2 over here, and log to the base of 10 of 1. And we know that this whole value, log to the base 10 of 1, it is equal to 0. So this whole value becomes 0. So E cell become 3.16 minus 0. This is it. So finally we got our answer, that is 3.16 volt. So for odd electron, what we have done, this is our concentration. So we have just taken the concentration and multiplied term. Square will be just because of this 2 power. This is our stoichiometry that we have shifted to that particular thing. So up to case 2 is also done. I hope you understood this one also. Now let's move towards the case 3. So this will be the last topic for today. Case 3 will be very much easier. Then we will, for tomorrow's lecture, next lecture, we will be talking about rest of the 2 things. Okay. So here we have a concentration cell. Okay. Always remember, third case is related to a concentration cell. Third case is related to concentration cell. So concentration is what? This anode and cathode. In this particular thing, I am writing few things, that anode and cathode, like, both will be same over here. Same half cell we have to take. Same half cells we have to take. Same half cells. Same metal, same solution. Same metal and same solution. For always remember, whenever we see same metal, same solution, it will be under the concentration. Same metal and same solution. It is simplified, same metal and same solution. It will be a simplified thing. Same metal, same solution. So what we are supposed to do over here? Same metal, same solution. Let's take an example of copper now. Copper is converted to from Cu plus 2, and here we have Cu plus 2 and copper over here. Same metal, same solution, and this we are taking 0.01 molar. This will be 0.1 molar, and temperature over here is 298 Kelvin. Temperature over here 298 Kelvin, and E cell, E naught of a cell value will be equal to 0. Always remember, because both anode and cathode are similar, so E naught value becomes 0. That's it. That is the meaning of concentration cell. So whenever we talk about concentration cell, always remember, in concentration cell we take both anode and cathode of same material. So this will be nothing but, let's solve this. Temperature 298 Kelvin. E cell will be calculated as, E cell, it is equal to E naught of a cell minus 0.059 divided by n log to the base 10 of Q over here. So now let's make it easier now. So here we have 0 minus 0.059 divided by number of n factor is 2, log to the base 10. Concentration is what? First one is 0.01 divided by 0.1. So here we get, this will be nothing but again 10 to the power, this will be nothing but minus 0.059 divided by 2, and this will be nothing but log to the base 10, and this will be 10 to the power minus 1. Minus 1 will shift to the front side, and here we get 0.059 divided by 2. So this will be the answer, that is 0.0295 volt. This will be our answer over here for concentrations. So today we have seen 3 cases over here. Now next cases we will be seeing in our next lecture. Till then, keep on studying. All the best. And if you have any doubt, please just send a message, or you can ping me on WhatsApp also, or on my number is also given. So all the best. Bye-bye.